Have you ever noticed how much things change around us? Trees grow taller, temperatures rise and fall, and cars speed up and slow down. Math gives us amazing tools to understand these changes. It's like having a secret language to decode the world around us. Imagine trying to describe how fast a cheetah runs. You could say really fast, but that doesn't tell us much. Calculus, a special kind of math, gives us the tools to be much more precise. It helps us measure exactly how fast things change, how steep a hill is, or even how much water a bucket can hold. The tools we use for this are called limits, derivatives, and integrals. Don't let the names scare you. They're just clever ways to describe things we already understand in a deeper way. These tools are essential for scientists, engineers, and anyone who wants to understand how the world works. Ready to unlock their secrets? Let's dive in. Imagine you're zooming in on a photograph of a flower. As you get closer and closer, you see more and more detail. Limits in calculus are kind of like that. They help us zoom in on what happens to something as it gets closer and closer to a specific point. Let's say you're heating water on a stove. You know that eventually it will boil. But what happens right before it boils? The water gets hotter and hotter, and the bubbles start to form more rapidly. A limit helps us describe what happens at that exact moment, right before the water changes from liquid to gas. Limits are like powerful magnifying glasses that let us see the tiniest details of change, even when things are happening very quickly. They help us understand what happens at those critical points where things transform. Now, let's talk about speed. Imagine you're driving a car. You can see how fast you're going by looking at the speedometer. The speedometer is telling you your speed at that exact moment. That's what a derivative tells us in calculus. A derivative measures how quickly something is changing at a particular moment. It's like the speedometer for anything that changes, whether it's the speed of a car, the growth of a plant, or the spread of an idea. Think about a rocket launching into space. At first it's moving slowly, but then it gets faster and faster as it burns fuel. The derivative tells us exactly how much the rocket's speed is increasing at every second of its journey. Integrals are like magic tools that let us add up tiny pieces of something to find the total. Imagine you're trying to measure the area of a strangely shaped pond. It's not a perfect circle or square, so how do you do it? You could use an integral. An integral lets us break down that complex shape into tiny, manageable pieces, like puzzle pieces. Then, we add up the area of all those tiny pieces to find the total area of the pond. Integrals aren't just for areas, though. We can use them to calculate the distance a car travels, the volume of a curved object, or even the amount of work it takes to move something heavy. They're like mathematical tools that can measure and sum up almost anything we can imagine.